In this video, we're going to find the first three non-zero terms of the Maclaurin expansion for f of x is equal to cos x. So suppose we could write cos x as a plus bx plus cx squared plus dx cubed plus ex to the 4 plus fx to the 5. So we're trying to approximate cos x as a polynomial. Please remember that x must be measured in radians. To do this, I'm going to use this GeoGebra app, which I'll put the link in the notes of the video. So here we have the graph of cos x, okay. Here we have f of 0, which is actually equal to 1. Okay, so if we put work out f of 0, we get this line here, which is not a particularly very good approximation. We can make the approximation better by, and f of 0 is 0, cos of 0, which is 1. We could try to make the approximation better by taking the next term, which will be f of 0 plus f dash of 0. If you differentiate cos, you get minus sine. Unfortunately, the sine of 0 is 0, so our approximation is no better, and this is actually a 0 term. So we will go to the next one, which is that. Okay, we can see now that we have a better, the red one's approximating to the green one, a better approximation here. So here, if we differentiate minus sine, you're going to get minus cos, but cos of 0 is actually 1. So if we take a half x from our first term, we will get a better approximation. Okay, when we do n is 3, okay, unfortunately we're going to get, if you realise by now, if you differentiate cos, you're going to get sine. Therefore, this is going to be 0 this term. So we've still got the same expansion, x plus a half x squared. So let's take n is equal to 4. Now you can see it's even slightly better approximation, just looking at the graph, okay. And so when we differentiate sine here, we get cos, and cos of 0 is 1, so we're going to have to add to this 1 over 24x to the 4th. Okay, so we have now got the first three non-zero terms, x minus a half x plus 1 over 24x to the 4th. And if we take n is equal to 5, the same thing will happen, because we'll end up differentiating cos to get minus sine, and sine of 0 is 0, so this term disappears. Okay, but we can see that first three terms gives a reasonable approximation. We can improve it, obviously, by taking better values of n. Okay. And by n is equal to 10, we've got a reasonably good approximation. Okay, and this is the general formula for Maclaurin series. Okay, so I hope you've understood. This video will be link will be put in the notes of the video, so I hope you can play around with the app for yourself. I hope you've understood, and I thank you very much for watching.